For an object in non-uniform motion, its velocity changes with time. Rate of change of velocity is expressed in terms of acceleration. Thus, if a body moves in such a way that its velocity changes, then it is said to be accelerating. Observe the car moving swiftly in the circuit. When it approaches the turn, it slows down and after negotiating the turn, quickly gains velocity again. Acceleration is the ratio of the difference of final and initial velocity to the time interval during which the velocity has changed. Acceleration is measured as meter per second square in the SI system. Like speed and velocity, the acceleration of an object can be uniform or non-uniform. A freely falling body gains velocity due to gravitational forces at a uniform rate. Thus, it shows uniform acceleration. However, a car negotiating a turn shows non-uniform acceleration because its velocity changes at a non-uniform rate. When an object moves such that its final velocity is less than its initial velocity, it is said to possess negative acceleration or retardation. Here, the two buses A and B are moving along a straight path. The bus A is gaining velocity, hence it is accelerating, whereas the bus B is losing velocity, and hence it is retarding. For example, consider a bus traveling with a velocity of 20 meters per second. The bus comes to halt at a bus stop over 5 seconds. In this case, the acceleration of the bus is -4 meters per second square. Thus, we say the retardation of the bus is equal to 4 meters per second square. A positive acceleration happens when you speed up. A negative acceleration happens when you slow down. This brings you to the end of this module. In this module, you have learned that when you measure the change in velocity with respect to time, you get acceleration. When an object moves such that its final velocity is less than its initial velocity, it is said to possess negative acceleration or retardation. A bus starts from a bus stop and attains a velocity of 24 meters per second in 30 seconds. When the bus is about to reach the next stop, the driver applies brakes. On applying the brakes, the velocity of the bus decreases to 4 meters per second in 5 seconds. You need to calculate the acceleration and retardation of the bus. According to the given data, we have two cases here. Let's examine each case in turn. In the first case, the bus starts from 0 initial velocity and gains a velocity of 24 meters per second in 30 seconds. Acceleration is equal to the ratio of difference of initial and final velocities to time. Therefore, the acceleration of the bus in this case is 0.8 meter per second square. In the second case, the initial velocity of the bus is 24 meters per second, which drops to 4 meters per second in 5 seconds. The retardation in this case is 4 meters per second square. Therefore, acceleration is 0.8 meter per second square. Retardation is 4 meters per second square.